Now let's move to our another topic, that is the moment of inertia matrix. As we have been known that inertia is the ability of a body so that it can resist the change in the motion which will occur in it. Now if we have been talking about a point mass, we will see that in the case of a point mass, the moment of inertia will be given by I is equal to mr square. Now if we have been talking about a 3D body, we will see that we can't take the whole to be as a one. We should have to consider it into point masses, and we should have to take its inertia with respect to x, y and z axis, which is given by the expression here. Now moving along, we will another topic which we will get is angular momentum. Angular momentum is equal to I into omega if we have been considering a single point. However, as we will move to a 3D body, we will see that this angular momentum we can't get by simply I into omega. Another approach which has been used is an moment of inertia matrix, which is of the form has been given here, Ixx, which is equal to dm into y square plus z square into integrated over m. And similarly we can get Iyy and Izz, and similarly we can get Ixy is equal to x into y into dm. Now we will see that in this case our Ixy is equal to Iyx. Similarly we have Ixz is equal to Ixz and so on. So we will see that this is an example of a symmetric matrix. Now moving towards the principal axis. Principal axis are special types of axes which are such that they will form a moment of inertia matrix, which is form a moment of inertia matrix which are diagonal matrix. That is, all the non-diagonal elements which have been present in it are zero. They are said to be principal axis, and such axis can moment of inertia corresponding to these axes can be found by using eigenvalue problem. And this can be done by equating this, which is our original matrix, towards this matrix. The value of the I which we get after doing so will be our moment of inertia corresponding to the x, y and z axis. Now rotation of the matrix, we will see that if we will rotate our 3D body, then we will see that initially if we want to calculate the moment of inertia about I cap, j cap and k cap, they are now changed to I dash, j dash and k cap. Now the new moment of inertia which we get, there is a relation in between the two, that is the old moment of inertia matrix and the new moment of inertia matrix, and that relation is been given by another matrix which is been given by I dot I dash, I dot j dash, I dot k dash and furthermore. Now if we will multiply the old moment of inertia matrix with this matrix, then we will get the new moment of inertia matrix. An example of this is the rotation about the z-axis. That is, if we will rotate the body about the z-axis, and the multiplication matrix which we should have to multiply with the old matrix will be cos theta sin theta 0 minus sin theta cos theta 0 into 0 comma 0 comma 1. Now this is all about the moment of inertia matrix.